Now, I've been dancing around this idea of reference angles, so let's really get into that idea of a reference angle. Reference angles are always acute angles with a positive measure formed by the terminal side of our angle and the x-axis. The idea is these things are always an express trip to the x-axis. They're not going to follow our regular angle talks. That's why they're called reference angles, not just angles. If it was just an angle, it'd just be an angle. But a reference angle breaks that rule of always starting at the positive part of the x-axis. All they care about is starting at a terminal side and getting to the x-axis as fast as possible. So if I drew a 210-degree angle, 210-degree angle would be somewhere down here in quadrant 3. So it's 210 degrees. Well, what's the fastest way for me to get to the x-axis? Well, it goes that way. That's the super fast way. So how far away am I from this 180 degrees right there? Well, 30. If I subtract 180 from 210, I get 30 degrees. So my reference angle, which is denoted by that little fish, the alpha, is my reference angle. If I had a 135-degree angle, I'd be over here in quadrant 2, because it's between 90 and 180 degrees. So there's 135 degrees. My reference angle, don't care about rules. All it cares about is starting at this terminal side and getting to the x-axis. That's all it wants to do. Notice how it's going in a different direction than the one before it. So 135 degrees, it wants to get to 180. So how far away is 135 from 180? Well, 45 degrees. If I add 45 degrees to 135, I'll get 180. So 45 degrees is our reference angle here. Note that one of them went clockwise and the other one went counterclockwise, but they're both positive. They're also always positive. 422 degrees, my goodness. So that's gone all the way around and then another 62 degrees. So it's somewhere there. So there's our 422-degree measure. All right, now here's our terminal side. We want to get to that x-axis as fast as possible. So how far away from the x-axis is 422 degrees? Well, it's gone all the way around, so it's 360. So really, if we wanted a coterminal angle with this thing, it would just be right here, which is 62 degrees. So it just needs to go back. It just needs to undo that. So my reference angle is going to be 62 degrees. Nice. Now, a quick reminder of these ratios. So 45, 45, 90 and 30, 60, 90 have particular ratios about them. So the hypotenuse is square root of 2. This side is, these two sides are identical. The one right next to the 30 degrees, I always remember, is the one adjacent to the 30 has got the square root of 3, so 3 and 3. The shortest side, the one across from the 30 degrees, is 1, or just an x. And then this side right here is always our 2x. Now, what we can do is, remember we did those proofs about 45, 30, and 60, is we can use those special values of 35, 45, 30, and 60 and reference angles in order to figure out the value of angles that are not 30, 45, or 60. We can use them in other places too. So check out this one. I want to find the exact value of the cosine of 210 degrees. I can type it in my calculator, but it'll give me a decimal. I want to know its exact value. So check it out. 210 degrees. It's right here in quadrant 3. So that's going to go right there. Now, let me first think about, is this going to be a positive value or a negative value? Well, all students take calculus. In that quadrant, tangent is going to be the only thing that's positive. So whatever happens, I know I should get a negative value on this thing. Now, let's connect that up and make a nice right triangle with a reference angle in it. What is that reference angle? Well, the quickest way to the x-axis is 30 degrees. And we know stuff about 30 degrees. The cosine of 30 degrees is the square root of 3 over 2. That's one of the things we just want to kind of have memorized from those proofs. But wait a minute, this 30 degree in this triangle over here is really just like kind of an upside down version of it. Now we could write in our side lengths. I'm going to make this one 1. I'm going to make this one, make this one a 2. We're going to make this one square root of 3, and we're going to make this one a 1. But this one is negative because it's going to the left, and that one's negative because it's going down. So we should just be able to do our trig stuff. Square root of 3 over 2. Negative square root of 3 over 2. So it's the same. Cosine of 30 degrees is going to be the same as the cosine of 210 degrees. You slap a negative on the thing. Oh, cool. Let's try out 495 degrees. So 495 degrees is going to be where it's going to be in the second quadrant. I'm kind of cheating off my notes here. I would add, I've got 360 degrees plus another 135 degrees. So that's our 495. Well, let's do that reference angle thing again. So there's my reference angle. It's just 45 degrees. Draw a lower right triangle by connecting that terminal side to the x-axis. Okay, well, 45, that one was 1, 1, square root of 2. Okay, and we know from our proofs that the sine of 45 degrees is square root of 2 over 2. Okay, this is talking, oh, I'm sorry, we're doing tangent. My bad. Tangent of 45 degrees is just 1. We know that from our proof. Now, this is in quadrant 2. And in quadrant 2, I know all students take calculus. I know in quadrant 2, whatever I get for this value, it should be negative again because sine is the only one that's positive in this quadrant. So look back at that 1, 1, root 2. That 1 on the x-axis, that's a negative 1 because we're going to the left. The one going up is positive because up is positive when you graph stuff. And the hypotenuse is always positive. So tangent is just opposite over adjacent. So it's just negative 1 over 1, which is just negative 1. So again, it based on that all students take calculus and what we know about 30, 45, and 60, we're able to figure out these things exactly. And that's it. That's it for today. There are a couple other things, but I think we'll handle that during class. It's a little bit easier to talk about it live rather than on our video. And I think this video's been long enough. So thank you so much for watching and have a good rest of your day. Bye-bye.